Hi, I'm Maggie Campbell and I'm a sailor. Today I'll be presenting the physics behind sailing, explained. This is me. Today we will be learning about what makes my boat move over the surface of the water. Sailboats are moved by the interaction between moving air, wind, and the sails. Sails make use of something called the Bernoulli effect to create lift and propel themselves forward. But before we can understand this, we have to ask ourselves the question, what is lift? Lift is, by definition, a mechanical force generated by a solid object moving through a fluid. In this case, the sail is a solid object moving through air, which is a fluid. A sailboat needs to generate enough lift to overcome the resistance it experiences from waves, eddies, and turbulence in the water, as well as vortexes produced by the air in the sails. Now that we know what lift is, we can learn what Bernoulli's principle is. Bernoulli's principle states that, within a horizontal flow of fluid, points of higher fluid speed will have less pressure than points of lower fluid speed. In other words, it's the inverse relationship between pressure and speed at a point for a fluid. Now, looking at the shape of a sail from above, you can see that it is very similar to the shape of an airplane wing from the side. This shape is called an airfoil, and is designed to create the maximum lift possible. When the wind hits the sail, it is split along the sail's leading edge. The air passes on either side of the sail at different speeds, so it reaches the same endpoint along the trailing edge of the sail at the same time. This curved shape causes the air passing over the backside of the sail to speed up and stretch out, because it has more distance to travel, which decreases the pressure on that side of the sail. The air flowing on the front side of the sail moves in a straighter line covering a shorter distance. Therefore, its relatively slower speed and higher pressure remain about the same as the original wind speed. Because all things tend toward equilibrium, the area of high pressure will try to move towards the area of low pressure. The air on the close side of the sail will push towards the far side, creating lift in that direction. The faster the wind is, the more lift it can generate, and the faster the sailboat can move. Now we are going to look at our example boat here. The lift created by a sail is roughly perpendicular to the orientation of the boat when the sail is halfway out, so it needs something else to help move it forward through the water. To fix this dilemma, engineers invented the keel. That's this thing right here. In ye olden times, before the keel was invented, sailors had a very hard time maintaining their course over the water. Their boats would slide sideways as the wind pushed them over the surface of the water. With the invention of more high-tech keels over time, sailboats have gotten much more efficient in moving upwind and across the wind. A keel is a wide but slim part of the boat that protrudes from the hull deep into the water. As the sails produce lift and push the boat across the surface of the ocean, the large surface area of the keel is pushed perpendicular to the water. The flow of fluid over the keel as it is forced through the water by the lift generated by the sails squeezes the sailboat forward across the surface. And that's it, folks!